Hi everybody, I hope you had a great spring break. I'm not going to be here this week, so I'm going to be giving you notes and a homework video every day. And you can use these notes and this homework on your test, which is a week from Wednesday, which is a 100-point test. Um, so make sure you take good notes. Make sure you give side notes to yourself, and make sure you do all the homework to your understanding. Because this test is next Wednesday, and I will not be here this week, so you're going to have to take good notes, rewatch the video a couple times until you understand it, and here we go. So this is Monday. Today is Monday, April 2nd, if you're wondering what day this is. I'll do that right here. Actually, I have a place. April 2nd. Today is properties of logarithms. Very important lesson on logarithms. It helps you simplify logarithms without using a calculator. Just little things like if you have long ones, you can make them you can condense them, or if you have one logarithm, you can express it as several logarithms. So you learned these in Algebra 2, and we're going to do it again. So here we go. Today you're going to be using the product property of logarithms, the quotient property of logarithms, the power property of logarithms, and then you're going to use the properties of logarithms together. So we're going to be doing all four of these. So starting with product right here. So in our first box here, we have product property of logarithms. It says if x, y, and b, look down here in this problem, x, y, b is the base, x, y are factors. If they are positive numbers, and b, as long as the base doesn't equal 1, then the following property is true. So it doesn't matter how many factors you have. If you have two factors, you will write this twice. You'll write base, log base b of the first factor, plus log base b of the second factor. So when you're multiplying, if you have one logarithm, this is called expanding. So we expanded it by writing a sum of two logarithms. So we had one logarithm with two factors, and we expanded it into a sum of two logarithms. So when you see a product, you're really going to add. The reason this works is back to exponents. When you have something like x cubed times x to the fourth, and I tell you to multiply these, you remember how we used to just add them? Okay, that's what we're doing here, because logarithms are just exponents. So it has to do with our exponent rules here. When you're multiplying, same base, you really just add the exponents. So we are multiplying with the same base. So it's really like adding the exponents. So that's what we're doing, and it looks just like a little bit different form. Okay, so you can also take it from expansion form into condensed form. So if you see something with a plus sign, that means you're going to take x and y, you're going to multiply them and write the base 1. So you can go backwards. You can go back and forth here. Back and forth. So this first one looks like we're going to take it in expanded form and write it in condensed form. So we have two logarithms. Notice both of their bases are 11. So we're going to condense. We're going to condense. We both have base 11 here. We're going to condense. So we're going to write one logarithm with a base 11. Okay, just one of them. You're going to take the factors 10 and 3, and instead of adding them, you're going to multiply them. So this answer is going to be log base 11 of 30. That's going to be your answer. If you punch this into the calculator plus this, you're going to get a decimal. If you punch this in, you're going to get the same decimal. This is another way of writing it. So on this one, again, we have a plus sign. So you're going to write log base 3. We're condensing into 1. We have 2. We can make it 1. You're going to take this 1/2 factor and this 12 factor, and we're going to multiply them. So it's log base 3 of 6, because a half of 12 is 6, and this is your answer. And the last one, we have two of them again. They both have the same base, so we can condense to 1 with log base 2, and we're going to multiply these. But you have to be careful. When you have parentheses like this, start with the one that's not in parentheses, put it out front. Put the one that's in parentheses here. So your answer would be log base 2 of x squared plus 2x. And I'd probably put that in parentheses. And that's how you do it. So they didn't really give you any where you had to expand. So let's just make up another one up here. Let's say log base 3 of 3xy. You had something like this. Actually, let's make this a 2. Let's make that a 2. So if you had 1 and I told you to expand it, you would write log base 3 times. I didn't really give myself a lot of room here. log base 3 three times, and you're going to put plus signs between all of these. Now, the 2 goes with the first one, the x goes with the second one, and the y goes with the third one, and that's what you would do. So that's the reverse way of doing it. So condensation to expansion. The quotient property of logarithms is very similar. So back to exponent rules. Remember when we had exponent rules like this? Does anyone remember how we did this? We'd write the base once, and we subtracted those. You got x squared. I mean, I used to tell you where's the most x's, and you would say top. How many more? You'd say 2 more. So that's how you do it, but you really are subtracting. So when you have something like this and you see division of 2 factors, you can expand it by writing a minus sign. So you take log base of the first one, x, but minus log base b of the bottom one. Okay? So let me just say, if you had log base 3 of x over 5, it would be log base 3 of x minus log base 3 of 5. And you'd be done. But now they're going to have you doing an expansion form down to condense it. So we're going to take this to 1 logarithm. So the base is 10, so you start with that, log base 10. But instead of 27 minus 3, we're going to do 27 divided by 3. So when you see subtraction, you're really dividing. So your answer is log base 10 of 9. And that's, oops, can you not see that? Log base 10 of 9. So in this one, notice, oops. See how this one's got a base 5 and this one's got a base 3? That means you can't do anything. Can't simplify. They have to have the same base. So be careful. And this one over here, we've got log base 3. We're going to take this top x squared plus 5, put that in the top. Where the minus is, that means divide the next factor, which is x squared plus 1. Now, you are not allowed to cancel out terms, and these are terms, and these are terms. So this is your answer. There's nothing else I could do to that. So you can put parentheses around top and bottom, but the whole thing's a factor, and unless you can factor that, you can't do anything to it. And this brings us to our third property, power property of logarithms. Now, if you have an exponent, so if you have an x and you're raising it to a power, what you're going to do is this thing is going to release, and it's going to come out front. The exponent is. See how we read it right here? It releases to the front. So it's r. Oh my gosh, you can't see. So sorry. Oops. So here's this exponent. So if you have a log base b of x raised to an exponent, the exponent is going to release out front as a factor. So that little exponent is going to become a big number out front. And it's going to be r times whatever this is. This helps to simplify and to solve logarithms. So this is a very important property for solving logarithms. Releasing that exponent out front. You can only release an exponent out front if there's a log in front of this base. So in this problem, you have a log, base 5 of x, cubed. This is not, I'm not saying this is a bad way of writing this, but the best way of writing this is take this 3 and move it out front. So it's going to be 3, big 3. See how it's little there? It's going to become big 3, log base 5 of x. So now it's 3 times all of this. Now this one's tricky. Whenever you see a square root, hopefully you know that the exponent for a square root is 1/2. What would the exponent be for a cube root? Cube root is really x to the 1/3. Fourth root is x to the 1/4. Keep that in mind. But this one's a square root, so it's x to the 1/2. So now this 1/2 can come out front, and that's your power property. So now we're going to practice some of these. Okay, so you can refer back and forth to the front if you want. So right now it says to write as a single logarithm. Condense. Okay, we'll be using the product and the quotient properties right now for these. So on this one, oh, actually we're going to be using all 3. The reason we're using all 3, see that r out front? If you see an r out front, that r out front can become an exponent. That's what's going to happen here. See this first one? You cannot condense these if there is a number out front. So what we're going to do with this 2 is we're going to move it back into its exponent form, and we're going to move 3 back into its exponent form. So this is the power property. So we write that. So using our power property, that's property 3, we're going to move this big number 2 and make it a little, we're going to shrink it to an exponent. So we're going to write log base 5 of 3 squared plus, now we're going to make this big 3 a little 3. We're going to shrink it. So we're going to have log base 5 of 2 cubed. So this is really, I mean, you don't have to do this step right here, but 3 squared is 9. We can make that a 9. And 2 cubed is 8. So we can go ahead and make that an 8. So now, when we condense, we haven't even condensed yet. Now we're going to condense. So log base 5, and when you see a plus sign, here, we're really going to multiply them. So we're going to multiply 9 and 8, like this. So your final answer is log base 5 of 72. Final answer. Wasn't that fun? All right, are you guys asleep yet? Wake up. All right, so this next one. There is a number out front here, so we're going to put it into an exponent. So we're going to use property 3. This is log base 9 of x cubed minus log base 9 of x plus 1. So there's nothing out front here, there's nothing out front here. So we're going to go log base 9. And then we're going to write x cubed in the numerator divided by, because subtraction means divide, x plus 1. We'll put all this in parentheses. And that is your answer. So this one, let's go. Well, we're going to condense. So you have log base 4. They're all base 4. So we're going to write it once. We're condensing the 1. When you see a plus sign, you're going to do multiplication. When you see a subtraction, you're going to divide. Okay, keep that in mind. So we're going to go 25 times 3 divided by 5. Now, simplify what you can. 25 times 3 is 75 divided by 5. 75 divided by 5 is, answer, drum roll, 15. And that's your answer. So we made that long problem simplify to this. So if you're going to punch this in the calculator now, you can just punch this in. But if you punch this in, plus this, minus this, and got a decimal, it'd be the same decimal as this. But I'm not asking for decimals, so don't give me decimals. So notice we haven't even needed a calculator yet. Write each expression as sums or differences of multiples of logarithms and expand. Okay, now, what you're going to do is expand this. This is called a single logarithm, and we're going to write it as many logarithms as factors that we have in the problem. So if you count, there's 1 factor, 2 factors, 3 factors. So I'm going to write log base 3 times. I'm spacing it out. Like that. So we're going to start with the 5. We're putting the 5 here, the 7 goes here, and the 4 goes here. Each of the factors gets its own logarithm. Now, because you're multiplying these, you should have a plus sign between the 5 and 7. And because you're dividing by 4, you should have a subtraction sign in front of the last one because you're dividing by that one. And that's your answer. That's called expanding your logs. Okay, so now we're going to do this one. So we have 2 factors. So we're going to do 2 logarithms. The x to the 5th goes with the first one, and the y to the 2nd goes with the second one. Because you're dividing, what should you put here, a plus or a minus? Hopefully you said minus. Now this would be an okay answer, but they don't like to leave exponents in log problems like this. So what they're going to do now is use property 3, the property that says this 5 can go out front. So we're going to write 5 log base 2x minus, and then bring the 2 out front. 2 times log base 2 of y. And that's expanded form, and that's your answer. So it says, use properties of logarithms to evaluate the following. Well, we don't know, we can't punch this in the calculator because it says base b. So what they do is they give you a hint. They're going to tell you that log base b of 2 is equal to 0.43, and log base b of 3 is 0.68. So if we can get the 6 in terms of 2 and 3, we can use these decimals. So how can I express 6 in terms of 2 and 3? The only way that I know, well, there's a couple ways, but I would do 2 times 3. That's still 6, correct? This is still the same problem. But then I would expand it. I would do 2 here and 3 here with a plus sign because you're multiplying them. So this is a single logarithm. I expanded it into 2. Now, log base b of 2 is right here. What is log base b of 2? It is 0.43. Log base b of 3 is 0.68. So if you add these, I'm going to have to line these up because I'm not going to use a calculator. 3 plus 8 is 11, carry 1. 4 plus 6 is 10, plus 1 is 11. So we have to be careful here. It's 11 and a 1. So your answer should be 1.11. That's your answer. 1.11. No calculator needed. So without a calculator, how can I do this one? Again, it's got base b. We can't use our calculator anyway. So can you use 2 and 3 to express 9? How would you express 9 using, there's a couple ways. Let's use I'm going to do the fancy way. 9, I know 9 is 3 squared. You could do 3 times 3 if you want and do it like this first one. You could do 3 times 3 and do it just like this one right here. I'm going to do a different way. I'm going to do log base b of 3 squared. And then I'm going to use that that power property to bring the 2 out front. So it's going to be 2 times log base b of 3. Now, what is log base b of 3? It's right here. It's 0.68. So we can substitute 0.68 in for log base 3 because they're equal. And then you can just multiply 2 times 0.68. So I'm not sure what that is, so I'm going to multiply 2 times that. 2 times 8 is 16. Carry 1. 2 times 6 is 12, plus 1 is 13. And then there's 2 decimal places, so that would be 1.36. Just so you know, you could have done this one as log base b of 3 plus log base b of 3, which would have been 0.68 plus 0.68, which still would have been 0.136. Okay, you can do it either way. So this one, let's write 2, square root of 2, as 2 to the 1/2. That's what square root of 2 is. Then we're going to release this out front using the power property. So it's 1/2 times log base b of 2. What is log base b of 2? It's right here. It's 0.43. So it's going to be 1/2 of 0.43. And what is 1/2 of 0.43? I don't actually know. I'm actually going to use my calculator on this because I don't even know what this is. 0.43 times 1/2. 0.215. Just borrow, if you don't have a calculator, just borrow from someone. Don't forget the following properties. Anytime you have a 1 right here, your answer is 0. So like if I said what's log base 3 of 1, you would say 0. If I said what's log base 4 of 1, 0. If I said what's log base 5 of 1, 0. This one says if you have the same property, right, same base, and that's an x there, your answer is x. So if you had log base 3 of 3 to the x, your answer would be x. If you had log base 4 of 4 to the x, your answer would be x. And if you have a number like this, log base 3 of something like this, 2, the 3's would cancel and your answer would be 2. This is just some properties from our last section.